There are several functions that we are going to see frequently in both this class and math in general. And what you may have noticed in the piecewise defined function section is that if we know the basic shape of these graphs, then that can be very beneficial when helping us sketch the graph. And that's going to be true when we work with transformations as well, because what we're going to find out is that if we know the basic shape of a graph and we know how to apply transformations, then we can quickly sketch the graph without having to find a bunch of points and worry about plotting those. So we're going to start first with the linear function, which is any function of the form f of x equals mx plus b. And so the key here is that we have x with a power of 1, and that makes it linear. And then also we have the m and the b, which tells us that we're not working with the constant or the identity function. So a linear function is going to have a graph that is a straight line. And that line could be rising from left to right, it could be falling from left to right, or it could be have a slope of 1 or a slope of 2, but it's always going to be a straight line. The constant function is a specific type of linear function, and you'll notice that what we're missing in the constant function is that variable of x, so that tells us, remember that f of x and y are used interchangeably, so y equals c is what type of line? It is a horizontal line. So we are always going to use a horizontal line to represent the constant function. The identity function is also a specific type of linear function, and what you'll notice about it is that its y-intercept is 0, there's no plus b on it, and that its slope is 1. So that means it is specifically the line that runs through the origin with a slope of 1. So these are all different types of linear functions, but we can learn a lot by knowing whether or not we have just a constant or an identity. So now let's move on and talk about the standard quadratic function. So that's just x squared. And hopefully you already know, but if not, the standard quadratic function is just a parabola. And it is a parabola with its vertex or its lowest point at 0, 0. Next, we have the standard cubic function, and I like to think of the shape of the graph of a standard cubic function as what I call a twisted parabola. So it's kind of like a giant grabbed a hold of the parabola on both ends and just twisted it around. And it also runs through the origin of 0, 0. So our cubic function has a basic graph that looks like this. Our square root function, if you think about the x values that we can plug in, we can only plug in positive x values or 0, non-negatives, and we can only get out positive and negative values. So it's actually going to start at the origin, and then it's going to kind of curve around like this. Now again, these are just basic sketches. I'm not plotting any points. I'm not being exact with these. It's just to give us an idea of what the basic shape of the graph is going to look like. The cubed root function is going to look similar to the square root function, but if you think about what the cubed root function means, it means that we can plug in negatives as well as get out negatives. So it's going to be a little bit flatter, and it's also going to go in both directions. So it's going to be a little bit flatter than our square root function, and it's not only going to go to the right, but it's also going to go to the left because we can use negatives in there as well. And then the last one that we're going to talk about is the absolute value function. Again, if you think about the absolute value function, we can plug any number we want to in, but we're always going to get a positive out. So the absolute value function is actually going to end up looking like a V with its point at 0, 0. So again, we're not being precise here. We're just looking at the basic shape of these graphs of the functions. But if you can become familiar with these, it will help you not only when you're trying to graph a piecewise defined function, but it's also going to be very useful when we start applying transformations to be able to sketch the graph of a function.